Welcome back, everybody. In this video, we're going to be sketching out context transition inside a DAX. Now, context transition is one of the first really gnarly ideas you have to wrap your head around in DAX, so one of the best ways to learn it is to see it visually. So with that in mind, I'm going to go ahead and sketch it out for you, and with that in mind, let me go show you that right now. So let's start off with what we might call a very simple data model. And by simple data model, I mean this right here. So we're going to imagine that we work in an office, right? I do work in an office, but this is a fictional office that I'm talking about here. And in this fictional office, we have a little vending machine where people can come in and for like 25 cents, a very, very low price, they could put 25 cents into the vending machine and they could get out some different things. They could get out coffee or tea or scone as they get in the morning, you know, to start off their day. So in order to keep track of this sort of discounted vending machine stuff, we have this very simple data model where we have a vend table that has all the different times somebody came up to the vending machine and pulled something out of it. It has the product ID of what they pulled out of it and also the time that they got it out, right? 7:31 a.m. or 8:12. Be sure and get to this office early or you're not going to get anything, okay? We run out pretty quick. So we've got these vending machine transactions in vend. Now, this PID column, that's the product ID column, that connects to, has a relationship with the prod, or products table, where we have the product ID, PID, which is either PCOF, PT, or PSCN, which corresponds to the actual products that you can get in the vending machine, coffee, tea, or scone. We also have a category for each one of those, right? Okay, so that's our pretty basic data model. We've got this fact table here with all of our vending machine transactions and this product table that has all of our products. Let's talk about the measure that we're going to explore today. The measure is going to be average transactions per product. So for all the different products that we've got, 3 of them, right, coffee, tea, and scone, what's the average number of transactions, the average number of actual items that people pulled out of the vending machine. Okay. Now, when we explore it, notice over here we've got a slicer for category, and nothing is selected. We're just going to assume to keep things, to keep an otherwise rather complex process a little bit simpler. We're going to assume 0 initial filters in our filter context. So no slicers, no visual level filters, no cross filtering, nothing like that. Nice and simple. Speaking of nice and simple, here's something less nice and less simple, which is our measure. Now, if you've been doing DAX for years and years, you look at this and you know how to dissect it with your eyeballs. It's not too tricky, but if you're looking at something like this for the first time, it seems like there's a lot of stuff going on here, right? So we've got our average transaction per product, and look at all this stuff. Now, over the course of this video, I'm going to show you the DAX sketch where we kind of sketch out all the pieces, but let's start with just a high flyover of what this thing does, right? Couple simple steps in here, or maybe not so simple, right? The very first thing this measure does is it's going to take the auto snapshot of the prod model table, right? So this is the table called prod in our data model, the model table. And in our measure, the very first thing that happens is we use this auto snapshot, which is to say when you type in the name of a table in your data model in DAX, if you don't immediately wrap it in a more specific snapshotting function, such as all or values, it assumes you want to take the auto snapshot, which is just going to bring back a temp table with all the visible rows of whatever table you type in right here, okay? So here where it says prod and it's underlined, we're going to bring back a 3-row by 3-column temp table that has all the visible products, keeping in mind that nothing is selected on this slicer. So this will bring back all 3 rows right here. So 3 rows by 3 columns, okay? So then what do we do with it? Well, we pass it into the average X iterator, and like all iterators, it's going to take the temp table that we produce right here and create a set of row context, or current rows if you want to think of them that way, right? And for each row context, it will run a per row formula in that row context, or run one formula per row. So the per row formula, an example of a sub-formula or sub-expression, is this sort of bigger box right here. All this stuff here is the per row formula, the formula that we're going to run once per row of the temp table that we got right there. Okay. So what do we do with each one of these per row formulas? Well, in each row, the per row formula is immediately going to use the calculate function to move or transition everything in each row's row context to a new filter context. This is essentially going to filter down to the current row or add a current row filter. And once these current row filters are in place, a filter for that row, Calculate will run its new filter formula, which is another kind of subformula. Up here we have the per row formula, which is this outer bit that runs once per row. And so once per row, we're going to run this bit, which has its own subformula, which is this right here, which runs once in the new filters that were set up by Calculate. Okay. So what do we do once we've got those new filters set up with the current row filter? Well, in each row, we're going to use the auto snapshot to get all the visible rows of vend, all the transactions for that row's product, coffee, tea, or scone. And once we get that temp table, we're just going to count how many rows are in it. And then when we're all done, we'll have three numbers, the number of vending machine transactions for each product, and we'll average them, and hopefully we get 3. We will, because I built this PowerPoint deck, and I made sure that I got the right answer before I started this recording. Okay, so let's actually go sketch this thing out. That's enough high level. Let's dig into the details a little bit. Okay, so let's imagine the initial filter frame for this guy, right? Now, if you haven't seen this concept before, when we're doing DAX sketches, whenever we run a measure, we imagine it running in a filter frame, which is basically just a box that we can do a bunch of stuff in that has a set of filters active, right? So because we've got no slashers here on category or anywhere else, we will assume that when this starts running, it will start running with an empty filter context. No filters at all in place, no initial filters. Okay, so in this filter frame where there's no initial filters, what do we do? Well, there's a bunch of stuff in here. We're going to start right here with this auto snapshot. So where we typed in prod, what DAX assumes is that what we want to do is take the auto snapshot and go get all the visible rows of the prod model table. There's the prod model table right there, right? And when we take this snapshot, it looks at the filter context and says, hey, are there any filters in place? Well, right now there's no filters in place, right? If there were, the snapshot that we took would pay attention to those filters. More on that in a little bit. But since there's no filters in place, the auto snapshot goes ahead and just gets all the rows of the products table and produces a temp table that we could draw like this, right? So when in DAX Sketch, when we talk about a temp table, we draw it as a little rectangle where we've got a description of what's in that temp table, all the visible rows. Then underneath it, we have the columns in that temp table. And here where it says star, that means all the columns of the prod table. So all the columns of this table right there. And this is, by the way, a 3-row by 3-column temp table. Now, in DAX sketches, we write out the contents of a temp table like this because usually these temp tables are quite big and they won't fit on the screen. Luckily, this actual data is quite small right here by design. So let me show you what that temp table actually kind of looks like, right? So here where I've got this temp table illustrated, sketched out, it is a rendering of this temp table right here. Right? Notice a temp table is different than a model table. This is the data we loaded from Excel or SQL or whatever. When we create tables in our measures, they are temp tables. They only exist long enough to produce a number, like this 3 right there, right? This particular temp table has 1, 2, 3 columns, one for product category, one for product description, and one for product ID, and it's got all 3 rows of data right there. So it's basically like a copy of that, essentially, because we got no filters in place. Okay. By the way, if we had a filter up here, like if I had clicked on, say, beverage right here on this initial slicer right here, we would have started with a filter for beverage, and then when we took this snapshot, we'd get these 2 rows, but not the last food row, because the filter for beverage would be in place, and the snapshot would only get the beverage rows. Okay, but no initial filters, so this just gets everything. Okay, so now that we got that temp table, what do we do with it? Well, if we look at our code here, the temp table produced from this auto snapshot, we pass into the average X function. The average X function is an iterator. What does that mean? That means it is going to take whatever temp table we give it and create a set of row context for it. Row context for it. And when we imagine that process of creating a set of row context, we draw it kind of like this, like it's a deck of cards. So each row in this temp table, average X will create a row context for. And once it does that, it's going to run a per row formula for each row context. Okay. Now, before we get into that, though, let me take this right here. Notice we've got 1, 2, 3 rows in the temp table, and we have 1, 2, 3 row context as cards here. what I'm going to do is I'm going to just kind of fan these out so we could see them in a bit more detail, right? So it's the same 3-row context, 3 rows. Let me just fan them out like, like that. There we go. Okay, so all 3 rows in this temp table, average X creates a row context for, right? It creates that one, and that one, and then it's going to run a per row formula in each one of these cards. The per row formula is whatever argument 2 of the iterator is, which is this whole thing right here, okay? So let me go back, sorry. So if we think about this temp table right here, I'm actually going to, rather than having it drawn down here, I'm just going to replace this with an actual picture of it, just because it makes things a little bit easier to understand, right? So that temp table that I drew actually looks like this. It's got 1, 2, 3 rows in it. And if we look at this and look at the row context, the set of row context created by average X, we could see that for each row in this temp table, we have a row context that looks like this, this, and this. So, if we think about the top row context, well, that corresponds to the first row right here. And all the values of that row, product category equals beverage, product description equals coffee, product ID equals pcoff, shows up here in the row context like this, as a set of named values, right? Values, text strings over here, that have names, product cat, product description, product ID, right? Just like that. And so that's the row context for the top row. Let's imagine what the row context looks like for this row right here. Well, not imagine, it's right there, right? So if we think about this middle row, when average X created a row context for this row, it created a row context with the following values. Product category equals beverage, product description equals T, product ID equals PT, because those are the values of that particular row. Row context is the equivalent of all of the values of that row, right? Sort of as named values right here. The values are the text strings, and they have the names over here. Bev is named product category, T is named product description, and PT is named product ID. Okay, now let's look at the row context of the bottom one. Well, you can probably see where I'm going with this, right? When average X creates this last row context, it looks at this third row in the temp table and creates a row context that looks like this, right? Since this row has the values of product category equals food, product description equals scone, and product ID equals P-SCN, well, the row context has those values, just like that, right? As a set of named values. Here's the values, here's the names, okay? Now, with that in place, right, let's think about the per row formula a little bit, okay? So for each row in the row context, we execute the per row formula, which is just argument 2 right here. Now, with a simpler measure, the per row formula would do things like, let's imagine this isn't a products table, but like a sales table. It would multiply the sales quantity times the sales price or something like that. But our per row formula, it starts off with the calculate function. Let's look kind of at what that does, right? So for every single row context, we're going to run the per row formula defined right here. This whole bit, argument 2 of average X, runs for each row, right? I typed in ... so I didn't have to type out the whole thing. So what does that actually mean? Okay, well, it means this. Calculate is going to create a new frame within a row within a frame. And it looks like this, okay? So what calculate does is it says, hey, I need to go create a new filter frame where the filters are different than what they were out here. And when calculate creates that new filter frame, because it is called within a row context, what it does is it takes all the values of the row context and adds them as a filter. It adds them as a filter. It adds them as a filter. So we can see for each and every row, which I render as a card, we have a new filter frame with a current row filter. Now, this filter, like all filters in DAX, is indeed a temp table, right? I describe it as the current row. It's got all the columns of product, and it's 1 row by 3 columns. That's true for all 3 of these. But even though, if you look at just the text of this one, and this one, they look identical, the contents of these filters is quite different, right? What do I mean by that? Well, because calculate, when it created its new filter context, it happened in this row context. It took all the values of the row context here and transitioned it into this temp table right here, which looks like this, right? And when calculate created the new filter context for this row, it saw these values in the row context and created a temp table that looked like this. And down here, when it did it in this row context, it said, hey, if these are the values of the row context, calculate, takes any values of the row context and adds them as a temp table in the filter context. And it looks like this here, right? So they're all called current row and they have the same dimensions, but this one is beverage coffee pcoff, this one is beverage tea pt, and this one is food scone pscn. Okay? So if we kind of take this guy over here and imagine what it looked like as a temp table, we could see essentially what we've done is we took the temp table from the auto snapshot here. AverageX created these sets of row contexts that basically took the current rows of that row, and that row, and set them up as named values. Then Calculates took those and added them as temp tables here, which are the equivalent of the first row right there. Actually, let's see. Hold on. I'm sorry. The first row is right there. The second row is right there. And the third row is right there. So Calculate took the row context and created that filter. Okay, good. So now that we've got those in place, what do we actually do with it, right? Well, the iterator AverageX had a per row formula, which is this whole block. Calculate has a new filter formula, which is just this little bit right here. So this bit right here, argument 1 of Calculate, is the new filter formula. An example of a sub-formula or sub-expression, if you want to use fancy terms. And this bit I've got right here is going to run in each one of these frames that we've created, right? So it's going to run in this filter frame with that filter in place. It'll run here with that filter in place, and it'll run here with that filter in place, okay? So we're going to run the exact same code, the exact same snippet of code, but because we run it with different filters in the filter context, we're going to get different results each time. Let's go look at that, okay? Oh, I'm sorry. I jumped ahead of myself a little bit. So with all this information in place, we can actually jump to a more formal definition of context transition, right? So what do we mean by context transition, right? Well, iterators always create a set of row contexts to run a per row formula within, right? The AverageX iterator took this temp table and created 1, 2, 3 row contexts, one for each row, set of named values. And then it will run a per row formula, this whole bit right here, not just this bit, but the entire thing including Calculate. It will run that once per row. Now, if the per row formula contains either Calculate table, or any measure, which we call the framers, those three things, calculate table, or measures, the framers, or revisers, if you've watched my Elements of DAX series, right? Then for each row, the row context is moved or transitioned into a new filter context. Because we've got in our per row formula here, Calculate, basically Calculate says, I'm going to take the row context and create a filter context out of it for each and every row. And now within these new filter contexts, one per row, one for this row, or one for this row, and this row, right? Then the new filter formula, there, and there, which I've defined in my code there, runs within each one of these frames. And then we'll get a number, and then AverageX will average them all up. Okay, cool. Let's actually go watch that. Okay. Oh, yeah, there's the actual tables in the filter context, right? That might help a little bit. Again, we go from this table to a set of row contexts. Those get moved into filter context, and then we go ahead and run our new filter formula in each one. We're going to get all the visible rows of Venn and count how many are in each temp table. Okay, let's go do that. So, in each and every frame, in each and every row, we're going to take the auto snapshot of the Venn table. This is the Venn table right there, so we're going to get all the visible rows of Venn. Now, keep in mind, it's all the visible rows, not just all of them. So for each one of these frames, we're going to get a different subset of this table right here. Let's go ahead and look at that. Okay, let's go back to this view just because it's a little easier to see what's going on, right? So in this filter context, we have this temp table. In this filter context, we have this one. And in this filter context, we have this one. So let's see what taking the snapshot does in this guy right here, right? So if we imagine this particular auto snapshot, well, with this filter in place, we've got a filter for beverage coffee pcoff right there, right? Because of the relationship, the filter on these 1, 2, 3 columns affects the Venn table, and therefore it's just these 1, 2, 3 coffee rows that are visible, right? So when we take the auto snapshot and say, go get me all the visible rows, well, what it brings back is these rows right there, which looks like that. We just get the coffee rows, right? Not all of them, just the coffee rows, or the vending transaction rows for this product, right? Coffee. Okay. So with that in place, let's look at this one, right? So now if we imagine taking the auto snapshot in this frame, in this row, right? Well, we're going to go get all the visible rows of vend. Because we've got this filter in place, well, that is on the category, description, and product ID column for beverage, tea, and PT. Because of the relationship between these tables, the filter, which affects these three columns, flows downstream and affects the vend table so that we just see, or we only have visible, these 1, 2 transactions related to that product, or tea more specifically. So when we take the auto snapshot here, what do we get back? Not the coffee rows, but the tea rows. Okay. Last but not least, if we come down to this bottom run right here, right, we're going to take the auto snapshot again, but this time we're going to do it with this filter in the filter context, where we've got a 1 row by 3 column filter for food, scone, and PSCN. Well, it's on these 3 columns right there, which are those 3 columns right there, right? And because of that, we have a filter for food, scone, and PSCN. Because of the relationship, that means in the vending table, only these PSCN rows are visible, these 4 right here. So when we take the auto snapshot, we're going to get these 1, 2, 3, 4 rows, like that. That is the temp table that this auto snapshot brings back. So notice we have the exact same code in each one of these frames, but because of the different filters in place, we just get back that rows, coffee, tea, or scone, rows in the vending table. Okay. So how do we actually draw these? How do we actually draw these? Or how do we sketch them? Maybe I should say it that way. Okay. So let me go back. So if we've got these temp tables here, we draw them just like we did everywhere else, right? And we say that for each row, we get the visible rows, right, of the vend table, and we get all the columns. That's what that little star means right here. And on this one, we have a 3 row by 2 column temp table. On this one, we have a 2 row by 2 column temp table, just the T rows. And down here, we have a 4 row by 2 column temp table, just the scone rows. Okay. Now, people that are paying close attention might notice there's a little plus after the 2 columns right there. So it says 2 columns plus, 2 columns plus, 2 columns plus. That is a topic for another video where we're going to talk about the concept of expansion or related columns. When you take a snapshot of a fact table, like here, vend, where there's another table that has a one-to-many relationship, you actually get some bonus hidden columns. Some bonus hidden columns from all of the lookup or dimension tables attached to it. But again, we're already trying to handle enough stuff in here, so let's go ahead and leave that for another video. Okay, so now for each and every row, we've got a temp table with all the vendor transactions, vending machine transactions for each row. What do we do with it? Well, if we look here in our code, once we've gotten all those temp tables right here where it says vend, we just count the number of rows in each one, right? So we're going to count the rows in that one, we're going to count the rows in that one, we're going to count the rows in that one. And just looking at our DAX sketch here, this one has 3 rows, this one has 2 rows, and this one has 4 rows. So as you would expect, the count rows function will return 3 for this row, 2 for this row, and 4 for this row. Okay. Now that we're done with all that, what happens? Well, this is actually kind of the final answer for each card. So for this card, we get the answer at 3. For this one, we get 2, and this one we get 4. Because we're using the average x function, average x will take those numbers, 3, 2, and 4, and average them up. Well, what does that look like? Well, that's just 3 plus 2 plus 4, the sum, divided by the count. So it's those numbers added together, divided by the number of numbers, 1, 2, 3. 3 plus 2 plus 4 divided by 3, so 3 plus 2 plus 4 is 9. 9 divided by 3, well, that's just boring old 3. And this, by the way, is where we get the final answer down here, okay? So after all of that, we get this pretty simple answer, but we could see all of the working pieces in here, and we could see how this context transition thing works. This context transition, wherein the iterator average x took the initial temp table that we got and created a set of row context, set of named values for each row to run the whole per row formula in. And then in our per row formula, we immediately call calculate, which takes the values of the row context and transitions them into the filter context as a temp table, where they act like a filter here, here, and here, affecting our snapshot, our auto snapshot event, which is why we get different temp tables in each and every card, which is why we get different numbers, which is why our average works correctly. So there is a lot of stuff in here, and I wouldn't be surprised, again, if you would benefit greatly from watching this video twice, but it really is worth the effort, right? I know we've covered a lot of stuff, but boy, if you can understand what I've covered just now and sort of see how it all works, you've actually mastered a surprising amount of the DAX language. So much of DAX is just sort of different variations of that. There's more to it than that, but that is definitely the hardest nut to crack, to just get those basic concepts. Okay, so with all that, I sure do hope that was helpful, and I will see you in the next video.